Section 1.7 Inverse Functions. If some physical machines can run in two directions, we might ask whether some of the function machines we have been studying can also run backwards. Take a look at figure 1 here. This provides a visual representation of that question. In this section, we will consider the reverse nature of functions. Let's say we have a function f here, and you have the input x, and we're going to have the output y. Is it possible for us to have this y as our input to get an output of x? Can a function machine operate in reverse? Let's have an example here. Figure 2 is the temperature from Monday to Thursday with the temperature in degrees Celsius. And what if we want to convert this to Fahrenheit? We know that the formula for degrees Celsius is equal to 5/9 of F minus 32. Let's use the first temperature, 26 degrees Celsius. We plug in that here. 26 is equal to 5/9 of F minus 32. And then we multiply both sides by 9/5. So 26 times 9/5 is equal to F minus 32. And F is equal to 26 times 9/5 plus 32. And this is approximately equal to 79 degrees Fahrenheit. What we did here corresponds to the idea of an inverse function. So what is an inverse function? For any one-to-one function, f of x is equal to y. A function f inverse of x is an inverse function of f if f inverse of y is equal to x. So again, we read this as f inverse. So take a note of that. A function f inverse of x is an inverse function if f inverse of y is equal to x. And keep in mind that f inverse of x is not equal to 1 over f of x. Okay, an example here. If f of x equal to 1 over x plus 2 and g of x equal to 1 over x minus 2 is g equals f inverse. So we can check with g of f of x and f of g of x. So let's start with this composition of function. G of f of x, that is, we start with f of x, 1 over x plus 2, substitute that to the x of g of x. So that's why we have 1 over x plus 2 minus 2. And 1 over x plus 2, if we get the reciprocal of this, that becomes just x plus 2. Minus 2, 2 minus 2 is 0, so is equal to x. Therefore, g is equal to the f inverse. With this, we can also say that f equals to the g inverse, but we can show that with f of g of x. So let's do that. So g of x inside the parentheses, and we know that g of x is 1 over x minus 2. We plug in this to the x of f of x. So 1 over x minus 2 plus 2, and minus 2 plus 2 is 0, and that becomes 1 over x. Get the reciprocal of this, that's simply equal to x. Next is finding domain and range of inverse functions. So whenever we have a function f, input a is the domain, and you're gonna have the output that becomes the range. This range, this output is now the input of the f inverse, and a is the range of the f inverse. So you will see here the domain and range of a function and its inverse. Example number 4, finding the inverses of toolkit functions. So if you remember all these toolkit functions, constant, identity, quadratic, cubic, reciprocal, reciprocal squared, cube root, square root, and absolute value function, make sure that you know all this. And we're going to identify which of the toolkit functions besides the quadratic function are not one-to-one, and find the restricted domain on which each function is one-to-one, if any. And these two are actually not one-to-one, the absolute value and the reciprocal square, and that is by using the horizontal test. So horizontal test, if you draw a horizontal here, as you can see that there are 2 points on the graph and the horizontal line. So both of them would fail the horizontal line test. However, if a function is restricted to a certain domain so that it passes the horizontal line test, then in that restricted domain it can have an inverse. Like for example, letter A, if we restrict it from 0 to infinity as your domain, then this is going to be, there will be an inverse for this. Same thing with here, the reciprocal square. If we only want this part greater than 0, then it will have an inverse. Or below 0 here for the absolute value function, then it can have an inverse. So that's how you restrict the domain. Next example, a function g of x is given. In figure 5, find g of 3 and g inverse of 3. G of 3 is equal to 1. So this is your 3 and your output is 1. Now, how do you get g inverse of 3? So remember, the beginning, you have the input 3 and your output is 1. And what if now you're going to have your input as 3, what's going to be the output? So if your input is 3, so look at this, then you will have 5. So g inverse of 3 is equal to 5. So from here to that, input to output. Next, find the inverse of the function of these two examples. The first one, f of x equal to 2 over x minus 3 plus 4. So let's solve this. That becomes y equals 2 over x minus 3 plus 4. Then subtract 4. Y minus 4 equals 2 over x minus 3. And then you can cross multiply or switch these two. X minus 3 is equal to 2 over y minus 4. And then add 3 both sides. Plus 3. And to get the inverse, f inverse of x, you just have to switch x and y. So this is going to be 2 over x minus 4 plus 3. Let's do the same thing for the next problem. F of x equal to 2 plus square root of x minus 4. So first subtract 2. And then add 2 both sides. Oops, sorry. My mistake. Why do we do that? Next, to get rid of square root is we square both sides. So y minus 2 squared is equal to x minus 4, and then add 4 both sides. And then now the inverse of x, you switch x and y, is x minus 2 squared plus 4. And that quadratic function with domain restricted to 0 to infinity, so that it can have an inverse. Take a look at this square and square root functions on the non-negative domain. Next example, given the graph of f of x in figure 9, sketch a graph of the inverse of f of x. So how do we sketch a graph of the f inverse of x? By looking at the graph, this is a one-to-one function, so definitely we will be able to sketch an inverse. So what do we see here? It looks like the range of this is from negative infinity to positive infinity. So meaning the domain of the inverse should have negative infinity to positive infinity. And what else? Here you can see that the domain here is above 0. That is from 0 to infinity. So we can say here that the range is above 0. That is from 0 to infinity. And for finding the inverse graph, that is by reflecting about y equals x. So reflecting over the line y equals x. So this one. So let's graph it. Domain is from negative infinity to positive infinity, and range is above 0. So from 0 to infinity. Also, we can see here 1, 0. So to get the inverse, we're swapping the x and y, or the inputs and the outputs, and then you're going to have 0, 1. So with that, we will be able to graph it. So look at this. The domain is from negative infinity to infinity, and the range is from 0 to infinity. So that is the graph of the inverse function of f of x. And yeah, this one. So the function and its inverse showing the reflection about the identity line. And that's it for section 1.7, and this is the last section of chapter 1. Thank you.